Here are 3 things you need to know about nitrates in your food. Now, you've probably heard about nitrites, nitrates, nitrosamines. It can be really, really confusing, and it really depends on context. There have been headlines about the dangers of nitrites, and there have also been headlines about the benefits of nitric oxide. So what are the 3 things you need to know? Number 1, it is all about context. Nitrates found naturally in vegetables and plants alongside those vitamins and polyphenols, those are beneficial for health because they are converted into nitric oxide, which is essential to many physiological functions that we're going to get into a little bit later. However, the same nitrates artificially added to meat products can lead to compounds that are created as a combination of the amines that you find in meat products and the nitrates that can lead to carcinogenic byproducts. We'll talk a bit more about that a little bit later. Number 2, there are clear health benefits associated with nitrate-containing plants and the consumption of those, including cardiovascular health benefits, brain health benefits, and exercise performance benefits. We're going to talk a lot more about those in a sec. And the third thing, if you're looking to support nitric oxide production internally and naturally, which I highly recommend you do, and you'll find out why. Number 1, eat a daily portion of nitrate-rich veggies. Later on, I'm going to give you the table of the highest nitrate-containing veggies, or to the best of our knowledge, what those are. Basically, beets and dark green leafy vegetables. We'll talk about the full list a bit later. Number 2, you want to make sure that you're looking after your oral microbiome, because your oral microbiome is the first point at which your nitrates are converted along a different a pathway to create nitric oxide. We'll talk a bit more about that pathway in detail. Number 3, you want to remove processed foods, processed meats, I should say, from your diet, because things like bacon, ham, these are things that are going to be potentially forming cancerous byproducts and actually stealing away from that nitric oxide production. And number 4 of this increasing nitric oxide production segment, you want to focus on other lifestyle factors that include daily sun exposure, exercise, and nasal breathing. Nasal breathing definitely does increase nitric oxide production. As a quick reminder before we get into it, these pods are here to open up the scientific discussion. I want to try and talk more openly about the scientific papers, but nuance is really, really important. And that's something that you probably don't hear on many social media platforms. No one really goes into the details. And this is what this podcast is all about. It's about food, it's about flavor, but it's also about going into depth into the scientific papers and giving you a balanced, nuanced perspective on the science. It's not, as simple as a binary statement of nitrates are bad or nitrates are good. It really, really does depend on context. That's probably the best thing I could say about any of these pods that you listen to. So in this pod, as well as those things that I've just talked about, we're going to go into what nitrates actually are, and the other terms that you've heard of: nitrites, nitric oxide, nitrosamines. We're going to talk about the controversy around those different compounds, how the body handles them, and their impact on health, and some practical takeaways from the research as well. So let's get into it. What are nitrates? So nitrate is a chemical substance. The formula is NO3. You don't need to know that. It naturally exists in our environment. It includes sources such as soil, water, air, plants. This is where you're going to find your nitrates. And it's part of the Earth's nitrogen cycle. So if you remember back to school, there's a diagram that I'm going to push up right now of the nitrogen cycle, of where we get different sources of nitrogen. It's fixed into the soil, plants absorb it. There's a whole cycle going on there. It's, in short, nitrogen is essential to life. It's a key building block of a number of different things. DNA, it's essential to plant growth. It's very necessary for the food we grow. And its balance in the environment is essential to all living things, including us and plants as well. For nitrogen to be used by plants and animals and humans, it needs to be converted into different forms, one of which is nitrates. So what about nitrites? So there might only be one letter differentiating nitrates and nitrites, but they are very different. It's another compound that occurs naturally through the fixation of nitrogen and oxygen as part of this nitrogen cycle. And in terms of chemical structure, both nitrate and nitrite contain nitrogen and oxygen. The difference comes in the number of oxygen atoms that they carry. That is about it. A sort of simplistic way of thinking about nitrates and nitrites is that nitrates that are used by plants and animals and humans are usable, and nitrates cannot be used directly. That's nitrites with an I. Nitrate is a more stable form. It can sort of chill out. It won't sort of react and go to a different form. Nitrites is more reactive. It's more of an intermediary that's quickly converted into other forms. So where do they come from? So nitrates we get externally from plants. That is the major source of them. It occurs naturally in the soil. Like I said, plants absorb it through their root system and they use it as a key nutrient for growth and development. And we get nitrates from the ingestion of plants, especially green leaf vegetables, beetroots. And the presence of nitrates in these different vegetables is dependent on a number of different things. The ingredient itself, but also the growing conditions, the season, the harvest, where the food is grown, loads of other factors actually determine the nitrate quantity in the ingredient, which is why, as we're going to get into a bit later, there is a huge variation in the nitrate quantity that has actually been measured across loads of different ingredients. So it's very hard for me to actually say beets and dark leafy green vegetables are the best sources, because there's a lot of variation between all those different ingredients. But in general, you can't really go wrong with beets and dark leafy green vegetables. Internally, our bodies can also produce nitrates. We'll get into a little bit more detail about it later, but it does show the importance to the human body if we can actually create these nitrates internally as well. So why do nitrate and nitrite get such a bad reputation? Well, it's typically because in their singular form, i.e. not in the form of plants, they're used in products like sausages, ham, bacon as a food additive. And in this context, they are linked to the formation of a group of compounds called nitrosamines, some of which are carcinogenic. But in the same way, the same ingredient, the same nitrate and nitrite, can also be converted into nitric oxide, which performs super important functions in the body, including signaling and vasodilation and some of the other performances that we're going to get into as well. As food additives, nitrate and nitrite salts are known to be associated with the meat processing. And I'll pull up a diagram here that just goes through all the different types of roles that these additives have. Color retention, they're antimicrobial, they improve flavor, they're antioxidants. They basically are a really good stabilizer for meat products and cheese products as well. They inhibit the growth of microorganisms. So this is why you'll see it on many different labels. It's not always referred to as a nitrite or a nitrate. So, for example, sodium potassium nitrate is also known as E251 and E252. Sodium potassium nitrite is also known as E250. So they have these E number denominations as well that you'll see in many. If you go to the supermarket, you'll see them on the back of processed meat packets as well. The problem that was first isolated was actually back in the 1950s. So there were concerns raised about the safety of using these products in meat processing because of the discovery of these nitroso compounds, these N-nitroso compounds, also known as NOCs, also known as nitrosamines. They're considered to be carcinogenic to humans, which led to regulation of these additives and their bad reputation as well. But scientists are still sort of investigating the role of these nitrates and nitrites. And in 2015, many people would have heard of the Cancer Agency of the WHO reviewing, or on the back of reviewing, over 800 articles. They actually classified these processed meat products as carcinogenic to humans, calling for a reduction of their daily consumption. Now, this was quite divisive for a number of reasons. Some people on one side were like, well, that completely negates the context of how people are consuming processed meat products. And, it can still be part of a balanced diet if you're having loads of vegetables with it, for example, or you're lowering your sugar intake, or you're lowering your saturated fat intake in other contexts. Other people on the other side were like, well, if it's type 1 carcinogen, why are we even allowing this to be part of our food system? And why are we saying reduce daily consumption? It should be your daily consumption is 0. And I think, I sit again in the fence of all these different things. It really, really depends on context, on how you're consuming these different products and how often you are. As someone who barely eats processed food, if any, I don't think it should be as black and white as a statement of this is banned and this is something that we can use every single day. I think there's a lot more nuance to this. This all doesn't sound very good, but it's not the end of the story. Because as we talked about, the same nitrate found in plants that are taken up from the soil compared to meats, they have a completely different impact on the body. When you consume these nitrates from vegetables, it actually leads to a reduction in the number of cancers. So how can the two coexist? How can you have the same ingredient or the same nitrate, and in one context it's potentially causing cancer, I should say, and the other it's associated with a lower risk of cancer? And the reason is quite basically is vegetables don't just contain nitrates in isolation. They also have a variety of other compounds, including polyphenols that we've talked about a lot in this podcast, vitamin E, vitamin C, and these can actually prevent the formation of nitrosamines and promote the formation of nitric oxide, which is important for human health. We're going to go into a bit more detail about how and why nitric oxide is so important. So the polyphenol combination and the vitamin combination that you find naturally in whole food plant products may be part of the reason as to why dietary nitrates from vegetables are not associated with increased cancer. In fact, the reverse. And they actually have a protective effect. So again, this really, I think this is a lovely sort of parallel, a lovely way of thinking about nutrition, because everything is context dependent. Nothing is good or bad. It really depends on what combination you are consuming a certain product in. I also think this is why nutrition is so fascinating. No one eats chemicals in isolation unless you're having a processed food and adding an additive to it. Food is a lot more than just a list of isolated compounds, natural food anyway. And I think, the combination of food and these individual chemicals naturally containing these hundreds, if not thousands of different polyphenols just goes to show that it's a lot more complicated than we think. And you can't really go wrong with whole foods versus processed foods. But the focus might be in the wrong place, because before the discovery of nitric oxide signaling, the focus was mainly on the harmful role of nitrates and nitrites as precursors of these NOCs and nitrosamines. But I think there's an important part to the nitrate story in their ability to serve as a substrate for nitric oxide. And why is nitric oxide so important? Let's go into some of the mechanisms of why nitric oxide is important before we go into sort of like the practical elements of like, okay, which vegetables you need to be consuming every single day. Okay, so if you're watching on YouTube, you're going to see the nitrate, nitrite, nitric oxide pathway diagram. And this essentially, for anyone that's listening, shows that after you eat a nitrate-containing meal, so something with dark green leafy vegetables, let's say, in the mouth, a lot of that dietary nitrate is reduced to nitrite, NO2, by the oral bacteria. So I've just mentioned the chemical formula there, but you don't need to know that. So it's just reduced from nitrate to nitrate by the oral bacteria, which is why at the top of this pod, I mentioned oral bacteria and not using mouthwash is super important. The produced nitrites are then swallowed, and then these are converted to nitric oxide in the acidic environment of the stomach and in other various tissues as well. So this nitrate, nitrite, nitric oxide pathway that you can see there is super important. What is the point of this pathway? Well, nitric oxide is actually a signaling molecule. That's probably the best way I would suggest thinking about this. And what that means is that it's involved in transmitting information between cells. It's essential for a ton of different physiological functions, including vasodilation, fancy word for vessels that dilate, so lowering blood pressure, for example, because you're reducing the pressure. If you think about like a hose pipe and you reduce the diameter of that, increases pressure. If you widen the diameter of that same hose pipe, it lessens the pressure. So that's a glib example of why vasodilatory effects of nitric oxide can improve blood pressure by reducing it. Neurotransmitter, and the sort of, just as a side tab to that, a lot of people ask, well, if I do have hypotension, i.e. low blood pressure, should I be looking to reduce nitrate containing products in my diet? It's a really good question to ask, and certainly that's not what we see in practice when people have a largely vegetable rich diet with hypotension. There's usually some other physiological mechanisms as to why someone might be having low blood pressure that are not related to a high amount of nitrate vegetables in their diet. And it doesn't seem that an inclusion of nitrate would worsen low blood pressure. So little side tab, because I have been asked that before at a talk I gave. It's also involved in neurotransmission, again, fancy word for transmitting those information between neurons in your brain. Immunity, skeletal muscle repair, super important as a signaling molecule. When the body doesn't produce enough of this nitric oxide, we see links to certain health problems, including high blood pressure. So this demonstrates that nitric oxide isn't just like one of these nice to have supplements or these nice to have things in your diet. It's really important to homeostasis, fancy word for balance in your body. So ensuring that you've got enough nitric oxide production is very important to ensure all these different things are working as they should be. So let's double click on a couple of examples of body functions that require nitric oxide, just to give you some context. I mentioned blood pressure. I think blood pressure is probably the most well understood. One of the most well documented roles of nitric oxide in the body is this dilation effect of blood vessels and blood pressure control. I'll pull up again another diagram for you to see what happens. The mechanism and the signaling pathway isn't that important, but I think it's quite interesting for people to understand just how important this is. So nitric oxide activates signaling pathways that increase a key messenger called cGMP that causes smooth muscle relaxation and blood vessel relaxation that widens the vessels, that reduces the blood pressure. So it has a real key role in cardiovascular health of your heart and your vasculature system. The second thing that I think a lot of people are quite interested in right now is blood sugar regulation, glucose metabolism, the fancy word for it. Nitric oxide has been shown to modulate change insulin, the hormone that's responsible for driving sugar from your blood vessels into various glucose sinks in your body, secretion. So nitric oxide changes insulin secretion and glucose uptake in skeletal muscle, liver, and fat cells. If you remember from a podcast I did a couple of months back, we talked a lot about glucose in the bloodstream and where your body drives it to keep your sugar out of the bloodstream and where it can be utilized by energy-consuming organs. Your sinks, the biggest sinks, are your muscles, your liver, and your adipose tissue. So the exact mechanisms as to how nitric oxide, also known as NO, how it does that are not fully understood, but certainly one of the mechanisms may be by increasing that GLUT4 transporter, also known as glucose transporter 4, on the membrane of cells. So it allows sugar to go from your bloodstream into adipose tissue, and it also has a vasodilatory action as well, so reducing the blood pressure. And you'll see from that diagram there about all these different functions. I won't go to every single one, but affects your mitochondria, affects the vasculature, affects your bone marrow. There's some really, really important ones. I will mention one other one, and that's brain function. So I mentioned earlier that nitric oxide is involved in neuronal signaling, so brain cell signaling, the communication between neurons in your brain. It also signals to other non-neuronal targets as well, like blood vessels. So it can actually help regulate functions of like controlling movement, energy, homeostasis, so the balance of energy, learning, memory, sleep, reproduction, anxiety. It's actually really, really important, as well as obviously brain blood flow as well. So ensuring you've got good nitric oxide levels is really important for all these different functions. It seems like it's a bit of like a master molecule that's super, super important. And after looking at the research, it kind of feels that way. I don't want to overstate the importance of nitric oxide, but you can't really go wrong when it comes to eating your green leafy vegetables and doing some of the other lifestyle factors that we'll talk about to increase your nitric oxide production. So now, by now you get the idea, right? Nitric oxide is important, has many functions in the body. So what we want to know is how we support our cells to produce balanced levels of nitric oxide in the body. And if I'm thinking about how to categorize these two things, number one, you want to don't do the things that reduce nitric oxide production. And number two, you want to do the things that increase nitric oxide production. So what are the things that reduce nitric oxide formation? Antiseptic mouthwash. Really, really interesting. So there's a paper that I will pull up the diagram for on YouTube so you can see what we're looking at. As I stated in the nitrite nitric oxide production, it's got me an easy way of saying this, but as I stated in that pathway, it starts in the mouth. And there's strong evidence actually that's accumulated over the last 15 years that shows using antiseptic mouthwash disrupts the oral microbiome, because our microbiome, really everything starts in the mouth. We've talked about this on the podcast with former dentist colleagues, and loads of people are really getting around to this idea that health starts in the mouth. The oral microbiome is so important for your digestive system. And in many ways, it's the early signal for things that could go wrong further downstream, whether it's your gut, whether it's your end organs. Lots of really, really good studies looking at the importance of oral health. Anything that disrupts that oral microbiome, so the population of microbes that live in your mouth, can disrupt your nitric oxide production as well. There was a study in 2013 in the journal Free Radical Biology and Medicine that found that the use of antiseptic mouthwash for 7 days reduced circulating levels of nitrite and increased blood pressure, which is pretty phenomenal. There was another study published more recently in Nature that also found that antiseptic mouthwash twice a day for 7 days was associated with a major shift in the salivary microbiome, lower nitrate concentrations, and a trend of increased systolic blood pressure. That wasn't statistically significant, but the caveat to that is that it was only after 7 days. And so any sort of inkling that it could be disrupting the nitric oxide pathway would lead one to believe that potentially it could have an adverse effect on blood pressure. So really interesting. And I think considering so many people use antiseptic mouthwash because they feel it's like a healthy habit to use, I've certainly changed my opinion on this. I would have used mouthwash maybe 3-4 years ago. I now definitely don't. For the nerds out there that want to know exactly what microbiome shift there seemed to be a greater abundance of firmicutes and proteobacterial species with a lower abundance of Bacteroides and Fusobacteria. And I'll put the links in the show notes as well. They're from the scientific reports and the Free Radical Biology and Medicine 2013 paper. Is it reversible? That's a really good question that I think would be natural to ask of anyone that is using one of these quite harsh mouthwashes, because they, it's advertised to them. You go to any pharmacy and you can see rows of this stuff. It's not really clear yet exactly how long the oral microbiota would take to restore its baseline function after using mouthwash for months or years. But there is some evidence that nitrate reducing function may be restored 3 days after mouthwash use. The question that I can imagine people asking right now is, if you are a user of mouthwash or have been for months or years, is ceasing mouthwash use going to be beneficial for the nitric oxide production? It's hard to say if you can return to the baseline level and whether a probiotic wash would improve the likelihood of you restoring your oral microbiome. But there is some evidence that nitrate reducing function may be restored 3 days after using mouthwash. So if you use mouthwash on day 0 and you wait 3 days without using any mouthwash, there appears to be some evidence that there is some improvement in the function of these bacteria that can change nitrate to nitrite, which is what we want for the production of nitric oxide. So potentially yes. But again, I would go to your dentist. I would make sure that you're not using mouthwash for a particular clinical reason. And in those cases, you really have to balance it with whoever your practitioner is. So number 2, what are the other things that can reduce nitric oxide formation that we don't want to do? Antibiotic use. In the same way, antiseptic mouthwash can reduce oral bacteria. Antibiotic therapy is also suggested to disrupt the oral microbiota and blunt the salivary action of reducing nitrate to nitrite. Again, it goes without saying, but I'm going to say it anyway. If you are on antibiotics, you're most likely going to be on antibiotics for a reason, and I would not cease it because you're trying to protect your nitric oxide formation. 100% you need to use antibiotics in certain circumstances, but we definitely want to be making sure that we are appropriately using antibiotics, as there is an abundance of overprescription in the US, in Australia, and certainly the UK as well. That's very, very well documented. Another essential player to nitric oxide formation that we want to make sure that we're not doing unless appropriate is low stomach acid. So as part of the nitrate, nitrite, nitric oxide pathway, stomach acid is necessary. A good level of stomach acid is necessary for the production of nitric oxide. So after nitrate is reduced to nitrite and it's swallowed and it goes down the esophagus and it goes into your stomach, it's first converted into an acidic compound called nitrous acid in the acidic level, in the acidic environment of the stomach. And if you look on the diagram that I've added that should be popping up on the screen on YouTube, you'll see what kind of happens along that pathway. So you get your dietary nitrate. In this case, they put a picture of beetroot, goes into the salivary, your mouth. The oral bacteria reduce it to nitrite, and then it goes into the stomach, and then you have the formation of these different intermediary products. So gastric acidity is actually really important for nitric oxide production. Now, this it questions the overuse and the abundance of prescriptions that we have available to us for high gastric acid levels. Now, I'm not saying that you should grin and bear it if you do have high levels of gastric acid, because that can lead to erosion of your esophageal wall. It can erode the cell lining. It can lead to higher incidences of gastric cancers. You've got to be really, really careful about that. But certainly the sort of pill popping nature of, I've got heartburn, I'm just going to take a Rani tablet, or I'm going to take a Meprazole. That's something that we shouldn't really be doing as habitually as I believe a lot of patients do, because the acidity of your stomach is a very, very important part of your digestive system. But as is exemplified by this particular pathway, it's also really important for the production of nitric oxide as well. In this particular study that I'll reference in the show notes, and you'll find this on the doctorskitchen.com website as well, when people took PPIs, also known as proton pump inhibitors or other antacids, that inhibited stomach acid production, it prevented the formation of nitrous acid from salivary nitrate, and thus nitric oxide release as well. So really, really important consideration when we're thinking about ways in which to not inhibit nitric oxide production. So what are the things that promote nitric oxide production? eating a healthy diet with sufficient nitrate kind of goes without saying. We'll talk a bit more about the exact vegetables in a bit. But as I mentioned earlier, the type of food containing nitrate has an impact on its fate, because it's not just a case of eating processed meats with loads of nitrate added to it. It's going to be the naturally occurring forms of nitrate that you find in dark green leafy vegetables, beets, etc. So what are the things that we can do to promote the beneficial effect of nitric oxide production? So number one, eating a healthy diet with plenty of nitrate-rich vegetables. I'll go through exactly which vegetables that are highest. Beets, dark green leafy vegetables are the best, and it's that combination of not just the nitrates, it's the vitamin C, the vitamin E, and the other polyphenols that lead to the formation of NO, nitric oxide, rather than the nitrosamines that can be that can be formed as a result of meat. There is a question of, if I eat some meat and I have it with tons of vegetables, does that negate the production of nitrosamines? It's a really interesting question, and I don't have the evidence to answer that at this point. I have looked and I couldn't find anything convincing, but my hunch is that yes, it probably would lessen the potential downside of consuming red meat or processed meat. Sorry. There was a really interesting study that I discussed with Professor Robert Thomas on the podcast on cancer. You can find it again on thedoctorskitchen.com by just typing in Professor Robert Thomas. And there was an interesting study where they looked at barbecued meats and combining it with fresh vegetables and plenty of herbs versus not, and looking at the production of polyaromatic hydrocarbons that we know are carcinogenic from grilling meats, and it appears to lessen the inflammatory effect of that. So there is a hunch that I have that potentially having loads of veggies with a small amount of meat could potentially mitigate against the production of nitrosamines, but I can't say that with my sort of evidence-based cap on, because I haven't come across a study of that. Number two, goes without saying, it's the reverse of the oral microbiota stuff. Don't use mouthwash. Supporting a healthy oral microbiota. I'd listened to the podcast that I did with Dr. Victoria Sampson, all about oral health recently. Ingested nitrate, like I said, is reduced to nitrite, and it does require good microbes in your mouth. So consuming things like probiotic-rich foods, kefirs, sauerkrauts, kimchis, would this have a beneficial effect on oral microbiota? Would this have an impact as well if you had a high fiber diet, potentially on your oral microbiota? I haven't come across anything that suggests using a probiotic toothpaste or a prebiotic-based toothpaste or a pre- and probiotic mouthwash has a beneficial effect on nitrite production, i.e. nitrate to nitrite. So I can't really suggest that. But generally looking after your microbiota, your gut microbiota, stands to reason that it would probably impact your oral microbiota in a beneficial way as well. Third thing, try and lessening the use of PPIs and antacids. And these are the fourth thing is some really interesting stuff around sunlight exposure, exercise, and nasal breathing. So on top of diet, it is suggested in some papers that lifestyle can improve the production of nitric oxide. Preclinical evidence, I want to emphasize this, preclinical evidence suggests that moderate UV exposure, so it's exposure to the sun outside, can increase nitric oxide by upregulating a particular enzyme that catalyzes its production. And so it's suggested that the equivalent of what we tend to suggest on a daily basis of 30 minutes in summer sunlight can increase can induce a transient burst of nitric oxide release that lasts for 48 hours, which is pretty phenomenal. So it kind of shows that, I shouldn't be inside in the studio, without any sort of natural sunlight. I should be making sure I'm going outside, going for a walk, midday sun, 30 minutes, in a t-shirt or shorts, so getting some sun exposure, because it's really important, not just from a nitric oxide production as exemplified by this preclinical study, but also from vitamin D production, from fresh air, and the the other benefits that we get to our circadian rhythm as well, to ensuring that we are regulating ourselves properly. The authors actually concluded that the release of the nitric oxide induced by moderate exposure to UVA in sunlight, which is different to UVB, may be beneficial for certain demographic groups, including the elderly, hypertensive patients, and those with impaired nitric oxide function as a result of PPI overuse, for example. So if you're older or you do have high blood pressure, this is your prescription that is free to go outside for 30 minutes every single day. You could be boosting your nitric oxide production. Super fascinating. But again, we don't have this. It's not something that I can point to a really, really clear evidence base for, but the harms are likely to be negligible, if not none. The authors suggested that nitrate consumption represents a simple strategy for cardiovascular protection. Very, very simple. And they used, in a lot of cases of these experimental trials that was part of this systematic review, they used food, things like beetroot, lettuce, spinach, really, really simple elements that you can add to your diet. They also did include some studies that use supplementation, but these were from whole food supplements. So something like a beetroot juice or a nitrite capsule that has been derived from a whole food. Really, really simple. And the fact that this study shows that it can reduce resting blood pressure, endothelial function, the stickiness of your blood by 18.9% is the exact figure that they gave. It's just something that should be plastered across most GP surgery doors, considering how widespread an issue cardiovascular disease is. It's a really low cost, effective measure to improve your heart health that has an impact on your brain health, that has an impact on the quality of your life as well. Exercise performance. I know I'm always asked about how can I get more gains in the gym? And the good thing is nitrate-rich vegetables can definitely help you do that. Dietary nitrate is actually one of the supplements that the International Olympic Committee consensus, the IOC, that they published a statement on this in 2018. It suggested that it can improve acute performance, and it has benefits to acute performance that are generally seen within 2 to 3 hours following supplementation. The exact dose that they've suggested is between 300 and 560 milligrams, and supplementation is proposed to improve your athletic performance through a variety of different ways, enhancing muscle fiber function, resulting in the improvement of high-intensity intermittent team sport exercise, usually around 12 to 40 minutes in duration. There was also a systematic review of randomized controlled trials involving 260-odd participants, and they found that dietary nitrate significantly increased maximal muscle power. So if you're going to the gym and you want to push out a high amount of energy and you want to do your personal best, whatever it might be, whether it's a squat, whether it's a bench, you may benefit from having a dietary nitrate supplementation, again, from a whole food. It could be in the form of beetroot juice. It could be in the form of a beetroot capsule. It's a really interesting additive to your exercise performance. That is something that is recognized by the IOC as well. Our understanding of nitrate is evolving, because I think the key question is, I get these benefits. I get the fact that it can improve my brain health, my cardiovascular health, my athletic performance. It all sounds too good to be true. How much should I be consuming? The honest answer is that it's not clear what dose of dietary nitrate from vegetables provides this array of health benefits. Several investigations have revealed the dose anywhere between 250 milligrams and 750 milligrams of dietary nitrate per day. That's a big, big range. And I think one's ability to extract the benefits of said nitrate really depends on some of the other factors as well. So things like exercise, things like your UV exposure, things like your oral microbiota, things like your stomach acidity, which is probably why you see this big, big range. I don't think you can go wrong with having at least one portion of high nitrate vegetables in your diet daily. And a portion, is around 80 to 100 grams. It was even suggested actually in the UK, where we have our 5 a day slogan, to have 5 a day plus one green leafy veg a day, which I'm a big fan of. I think greens should be included in the slogan. We should all be having greens every single day. I pretty much have a high nitrate green every mealtime, including breakfast. People think I'm weird. I actually think it's something that is pretty evidence-based. There's a lot looking at nitrates in general. Despite me actually saying to everyone that you should be getting it from your diet, I know people love a supplement. And I don't have anything against supplements. I think I'm more on the sort of side of whole food supplements. But if you are going to supplement with nitrates, how much should you be looking for? What is the safe limit? So the WHO actually established an acceptable daily intake a few decades ago, and they suggested a maximum of 3.7 milligrams per kilogram of body weight. So that is around 260 milligrams per day for a 70 kilo adult, which doesn't actually sound like that much. And then we also looked at examine.com, which I tend to use quite a lot for evidence-based articles and certainly evidence-based information around supplementation. And they suggest nitrate supplementation of 6.4 to 12.8 milligrams per kilogram. So almost double what the WHO said a few decades ago. And that equates to about 450 to 900 milligrams of nitrate per 70 kilogram adult, which is not really the average weight of an adult these days, but it's the sort of norm, the consensus. So if you were looking to supplement, that's generally what an upper limit could be. I want you to think about food. So what foods are the highest in nitrates? And what is this one nitrate-rich vegetable that you should be having every single day? Well, it really depends on like your own sort of preference for food, what you feel is easy to attain in your daily diet. And honestly, when we looked at this, the team and I, an up-to-date nitrate food composition database of plant-based foods is lacking. We didn't find a standard database that contains detailed and accurate information about nitrate content of vegetables. The majority of studies actually rely on estimates of food nitrate content obtained from various sources. Plus, the majority of the databases that we looked at look at nitrate levels in raw food, not considering the impact or the effect of cooking processes like steaming, boiling, sauteing on the nitrate content of foods that we consume. So there is that sort of caveat before I go into exactly which foods are the highest. A group of researchers recently developed a reference database for assessing dietary nitrate from a large variety of vegetables. You'll see this pop up on YouTube right now. There is an article right at the bottom, which is called Leader et al. From the British Journal of Clinical Pharmacology. And they included data across 260 different plant-based foods from 64 different countries. Overall, it shouldn't come as a surprise really, but overall, dark leafy vegetables were the top nitrate-containing foods, followed by stem and shoot vegetables, herbs and spices, and then root vegetables. More specifically, the highest nitrate foods, i.e. those that have 100 milligrams per 100 grams of the ingredient. So if you think about it in context, if you're trying to get to that 300, 400 milligram dose, that is like for an average 70 kilo adult, you want to be having 300 to 400 grams of this particular ingredient. Beetroot, spinach, rocket or arugula for our US friends, lettuce, and celery. Vegetables that tend to be in the sort of medium range, so sub 100 milligrams per 100 grams of ingredient weight, are things like green beans, cabbage, leek, and turnips. So you're still getting some nitrates in your non-typical nitrate-rich foods by just having a variety of these different ingredients into your diet as well. Like I said, this is based on a paper published in the British Journal of Clinical Pharmacology in 2013. You'll see it on your screen now. You can download it again from the Doctor's Kitchen show notes on the website. And look, if you really don't like your dark leafy green vegetables, or you can't get enough, you could think about whole food supplements. Now, we've done a whole sort of podcast, YouTube video on supplements. I am a fan of whole food supplements. I think you probably need to consume quite a bit. So most green powders, for example, will have like a big tablespoon that you put into a drink. But actually, when you do the math and you think of, okay, I've got an ingredient that weighs 100 grams and I dehydrate that down into 30 or 40 grams, am I literally getting 30 or 40 grams of that ingredient? And how much of said ingredient am I getting? If it's got 70 or 80 different ingredients in it, where are the benefits coming from? And are there any studies to demonstrate that there are benefits from consuming that sort of daily nitrate-rich green powder? I haven't come across much. Honestly, I haven't done a deep dive into it yet, but I will do because I get asked about it a lot. I would recommend, if you are going to take a nitrate supplement, I would ensure that you're speaking to your health professional and really determining whether it is for a specific need, and be rigorous about how you're going to test whether that supplement has a beneficial effect. It could be how you feel, it could be a blood pressure measurement. I think it's really important to be intentional about any supplement that you take. Why am I a sort of proponent of whole foods or whole food supplements? It doesn't, an isolated compound doesn't have those beneficial additives, the entourage effect of those polyphenols and vitamins that mitigate against the lesser effects. It doesn't mitigate against the fact that this can be pushed towards nitrosamines that have potentially a cancer-forming effect. I think you can't really go wrong with whole foods, and that's why I'd be a lot more comfortable with people just diving into dark green leafy vegetables and other nitrate-rich vegetables rather than taking supplements in isolation. So if you got to this far, let me just give you the takeaways from the research that I feel that you can apply to your daily life. I've got 5 practical takeaways for you. Number 1, remember, eat your daily green leafy vegetables. Rocket, spinach, arugula if you're American, lettuce. Try and have at least one portion a day to your meals. One portion is like a cereal bowl or a dessert bowl of leafy greens. And it's something that a lot of the longest living populations generally have. In Greece, they have horta, which is like one of my favorite ingredients, one of my favorite dishes. It's just wilted greens. It could be nettles. It could be wild greens. Bit of olive oil, so you're getting that olive oil, you're getting all those different polyphenols there. Lemon juice to increase the absorption of some of those, the iron that you get in dark green leafy vegetables. A great thing to always have at your dinner table every time you sit down to eat, your main meal, your lunch, whatever it might be. I'd swap out meat products. Number 2, I'd swap out meat products like ham, bacon, and sausages from your daily meals and treat them like an absolute occasional luxury item. And I would diversify your protein sources with things like grilled tempeh. Could be eggs, could be fish, could be mashed chickpeas, grilled mushrooms, lean cuts of meat. Fine, but I would be really, really careful about the meats that have nitrates added because of the nitrosamine effect as well. If you are going to eat meat, this is number 3. If you are going to eat processed meat, I'd combine them with vegetables to potentially mitigate the effect of that nitrite to nitrosamines effect. There might be an effect of the vitamins and polyphenols that you have with vegetables, but I can't say that with any certainty, and I can't point to evidence-based, but it is my hunch, and that's my caveat there. Number 4, drop the mouthwash unless you are prescribed it by your dental practitioner, especially antiseptic mouthwash. That is like an atomic bomb going off in your mouth and just getting rid of all those microbes. You really, really don't want to have that as a daily health habit because you're disrupting the oral microbiome that we know is not just important for nitric oxide production, it's also important for the homeostasis of your mouth, which is the first part of your digestive system. So people who have gut problems might have issues actually a lot further up, and that's probably best to first address. So chewing your food appropriately, ensuring that you're having a good collection of different probiotic and fiber-rich foods. These are things that I would suggest thinking about first. And number 5, think about the other activities that can increase nitric oxide production. Sunlight, exposure, and breathing practices. We didn't really dive too much into the nasal breathing practice, but certainly whenever I'm walking around or I'm in a supermarket queue or I'm waiting at a station, I'm always really conscious to breathe through my nose, out through my mouth, through my nose, out through my mouth. And that has been shown to increase nitric oxide production as well. It's also something that has a very calming effect. We should do a deep dive into nasal breathing in general, actually, because I think a lot of people are interested in that. And I think as a daily practice, nasal breathing, fantastic thing to do and just something to get used to, and being more conscious about how we breathe and our posture, with the potential benefits that it could be lowering our blood pressure, improving our brain health, and improving our metabolic health as well. And get your UV exposure. Super, super important generally, may have an impact on your nitric oxide levels as well. And then an extra one, if you've really listened to the end, is think about whether, if you are taking antacids or PPIs, finding long-term alternatives with the help and the support of your health practitioner. We will be doing a deep dive into GORD, gastroesophageal reflux disorder, and gastritis more generally, because again, I think it's an issue that can be helped by changing your diet as well as some other lifestyle practices. But yeah, that's definitely something to assess if you are on long-term antacids, thinking about other things that could improve your gastritis symptoms. There's so much more about this topic that I would have loved to have gone into, but this is sort of our take on a very controversial subject regarding nitrates and nitrites. I hope you've understood. You now understand with confidence where nitrogen comes from, why it's important to your body, the difference between nitrate, nitrite, nitrosamines, why that's important for nitric oxide production, what nitric oxide production actually does for your body, cardiovascularly, metabolically, neuronally, and also ways to increase nitric oxide production, not just through food, but also through the other lifestyle factors as well. And if you enjoy this, I'll see you next time on the Doctor's Kitchen podcast. If you like that video, then you will love the full library from the Doctor's Kitchen podcast. We talk about inflammation, immune health benefits, and much, much more about food as medicine, including this video right here that you can click through right now.